All right, so we're looking at 9.2. Our learning target today to start us off is we're going to be able to determine the experimental and theoretical probability. So for the most part, so say I have 10 marbles in a bag, 3 of them are green. What is the likelihood I pull out a green marble? 3 out of 10, right? There's 3 greens in there, and there's 10 marbles total. So for the most part, you guys have probably seen theoretical probability questions. Today we're going to compare that to experimental probabilities, and that's what actually happens in experiments. So do some of you have quarters on your desk from last class? Yeah. Probably wondering. We're going to just run a little experiment to compare. So first, I want us to define a couple things, right? We haven't talked about probability at all this year. So let's make sure we know what probability is. It is the likelihood of an event occurring. It's always going to be a number between 0 and 1. If you wind up with a number bigger than 1, you've done something wrong. Sometimes people like to write it in percentages. So a number between 0 and 1 is the same thing as 0% to 100%. Now the next thing is an outcome. So an outcome is all the possible results. Right? We're going to want to talk about, okay, what are the different outcomes that I could get with these particular events? And sometimes it will be just one event, sometimes it will be multiple events, it just depends. So what is an event, right, when we talk about probability? Well, it's getting one or more outcomes. An event could be anything, right? Flipping a coin, rolling a die. But it also could be winning a race. And then last but not least, a sample space. So we're going to have to come up with our denominator. The denominator of probability questions is always, what are all the possible outcomes? What is my sample space? So let's talk about some different sample spaces. Let's make sure we know how to figure out how many different options are in some sample spaces. Anybody need more time? Okay. So 3 coins are going to be flipped. List all the possible outcomes. So sometimes we have to make a list, right? Sometimes you're going to get a probability question and think you know the answer, and then you start thinking about it some more, and like, maybe I need to write out some of the possible ways, okay? So in this case, 3 coins, I could get a head, and another head. Or I could get a head, a tail, and another head. Or a head, and then a tail. Or a head, a tail, and a tail. Trying to think of all the different ways. If I flip a head first, what are all the other combinations that I could have there? That seems about right. Now our next one, let's start off with a tail. I could get tails and then heads and then heads. Tail, head, tail. Tail, tail, head. Or tail, head. Oh, I already had tail, head, head. Need a different one. We got tail, head, tail. Which one am I missing? Tail. Tail, head, tail. No, I got tail, head, tail. Tail, tail, tail. Tail, tail, tail. Thank you. The big one. So how many are in our sample space? 8. So my denominator for this type of question is going to be 8. So if I end up asking, okay, what's the probability I get tail, tail, tail? Well, it's going to be 1 out of 8. All right, let's look at our next one. You flip a coin and then roll a 6-sided die. So these 2 events, right, still independent. Flipping a coin, rolling a die. I could get heads and a 1. This one's a little bit easier. I'm not going to lose my place here. And then I've got the same thing with tails. So how big is this sample space? 12, right? 6 from here, 6 from here. So now that we've kind of written these out, what's the more mathy way to do it, right? We're going to have options where it's not just flipping a coin. So let's look at our first example that we had here. I had 3 different coins. Let's say they're all different colors, so they're all very independent. We can kind of keep them separate. How many options do I have when I flip the first coin? Heads or tails, right? Just 2 options. And then I can do that same thing with the other 2 coins. So I get 2 times 2 times 2. I get 8 total options in my sample space. Down here, I have 2 options for the coin, and then 6 options for the die. So 2 times 6. That's where we get the sample space numbers. And we're going to practice a lot of that today, is finding those sample spaces. So let's get to our learning target, right? If we're going to determine the theoretical and experimental probability, let's make sure we know what that actually is. So let's algebra 2 it up, right? This is the notation that we like to use. It looks a lot like function notation. So what this means is the probability of event A. So you're going to start to see, right, us using those types of notation for probability as well. So the probability of event A occurring is the number of probable outcomes in event A divided by the total number of outcomes available. Notice, right, we have a fraction. So when you see the word probability in a question, make sure you have a numerator and a denominator. Let's look at some different examples. If you're equally likely to choose a number between 1 and 20, what is the probability you choose a number divisible by 5? Right, so how many numbers are in our whole sample space? 20, right? 1 to 20. So that goes in my denominator, in my sample space. Now, how many numbers are divisible by 5? Well, let's list out what they are. Okay, what are the numbers between 1 and 20 divisible by 5? 5. 10. 15. Perfect. So that means I have 4 out of 20. And yep, I like to simplify fractions. 1/5. All right, let's look at example 4. If a pair of die is equally likely, so it's a 6-sided die, is equally likely to land on each number, what is the probability that the sum is 7? Let's talk about the sample space first. Right, we have 2 different die. I know I'm going to have a numerator and a denominator, right? So it's probability. So for the first die, how many options?
6.
Second die.
6.
So that means my sample space is out of 36. Now let's talk about the different combinations to make 7. We got 4 and 3, but then we also got to think about 3 and 4. We got 2 and 5, and then we got to think about 5 and 2. And we got 1 and 6, and also 6 and 1. So everybody turn to the last page of your note sheet. You're going to see this nice little chart there, as well as a deck of cards. Is everybody here kind of familiar with what's in a deck of cards? I don't assume that we are all gamblers at heart, okay? So I'm going to give you this information on a test. You're going to have access to what a deck of cards looks like, in case you don't know, and also just 2 die flipping over. So, right, I have like the 2 and the 5 here, but then I also have the 5 and the 2 up here. So that's where we see all those different combinations. So I wind up with 6 out of 36. But use that as a helpful guide. You'll even see it on your final exam. I usually put it in the front, right? It's almost like your unit circle, just another reference you can use. And then we simplify this down to 1/6. Questions on theoretical probability. All right, let's look at experimental probability. This is what actually happens. So when we define the probability, we still use that same notation, the probability of event A occurring, but now I'm going to base this on historical data. How many times did the event occur over how many times I've actually run a trial? How many trials have I run? Okay, so I know that you guys don't have colored notes, sorry about that. So we've got the spinner down here, it's got red, yellow, blue, and green, and let's just assume that every single quadrant is the same. So those are 4 even slices of the spinner. I have spun the spinner how many times? 19 times, and these are the results that I've been able to get out of it. So what is the theoretical? We'll just talk about theoretical. What's the theoretical probability that the next spin is blue? 1 out of 4, right? I've got 1 blue square out of 4 potential blue squares. So that's my theoretical probability. Now the experimental probability is how many times did we actually land on blue? 4. So it's 4 out of 19 spins. So I don't think of this as like the next spin. I don't add 1. I just take the data that is given to me and set up my fraction that way. So let's look at the next one. The next spin is going to be green. What's the theoretical probability? 1/4. And the experimental? 3 out of 19. I got green 3 times on that spin. Okay, what we're going to do, we need everybody to, or every group to have a quarter. We're going to do some experimental versus theoretical. If I flip a coin, what's the probability it's going to land heads? 1 out of 2, right? 50% shot. So we're going to see. Why don't the 3 of you work together? You've got a coin, so why don't you and Owen work together? Do you 2 have a coin? You got one? Yes? Okay. You 2, you've got a coin. You 2, one of you got a coin? No. There we go. You 2, you guys got a coin? You guys have a coin? No? Okay. So we got our groups. Here's what we're going to do. Each pair, so I don't want to like flip an all day here. Each pair is going to just flip 20 times, and you have to keep track of the number of heads. So make sure you only each flip 20 times and keep track of the number of heads. We're going to combine all of our data together and put it on our spreadsheet. So we've got how many groups? 1, 2, 20 times total for the two of you. Yep, so if you want to stop, don't throw your coin around the room. Alright, you gotta let that one flip it.
Yeah, that was one. 6 out of 10.
You got one.
Even counts.
You gotta put your finger nice.
I just like flipping heads. All I do is I just flipping heads.
Still flipping. Oh my gosh. Where we go? Alright, did you get a perfect 10 out of 10? No. We'll see if we do. We'll see if we get close as a class.
I wasn't before.
Are you kidding me?
Oh, when the smell is coming in.
Only too short for me.
The smelly things, when are they coming in?
Oh,
Let's
this
go.
Alright, does everybody have their data?
13 up.
Alright, we're gonna go around the room and I'm gonna put it in my spreadsheet here. We're gonna see how close the class came to the experimental probability of what we expected. Up here in front, what did you ladies get? How many heads?
7.
7 heads. Owen?
11.
11. Graydon?
10.
Oh, perfect. All right. Wyatt?
7.
7. Alyssa?
12.
12. Ava?
9.
9. Rowan? 13. Let's see. Oh, that's much better than the last class. They got 43%, not even close. So, right, the idea is that we want these two things to match, but in the real world, that's just not the case. Now, if we stayed here overnight and flipped coins for the next, 48 hours, the more flips we have, we would get closer to that 50%. But that's the difference between experimental and theoretical probability. Right, I'm going to give everybody about 8 minutes to do your homework assignment, which is that 9.2 worksheet. But I want to talk about a couple of the questions on there. The last class had some questions about it. So, let's look at number 7. First of all, I tried to, write a little different of a spinner question, but it seemed to confuse them. I probably should have just gone with what was in the notes. So for number 7, I only spun the spinner 5 times. So that table shows what I got. So the first spin, I landed on a red, the second spin, an orange, and so forth, okay? So I'm basically telling you what your denominator is already for that one. And then the one that they really had questions on, number 4. Joanne knows that Claire's birthday is in November, but it does not fall on an odd-numbered day. So what's the probability that Joanne can correctly guess Claire's birthday? So first of all, right, Joanne knows certain things. She knows that it's in November, and she knows that it's not on an odd-numbered day, so therefore it must be on an even-numbered day. So in terms of her sample space, if she's going to guess, right, she's not going to guess the 3rd, right? That's an odd number. So how many even numbers or even dates are there in November? That is your denominator, okay? So go ahead, like I said, I'll give you, I might just do 7 minutes. I'll be walking around. Let me know if you have questions. And then we'll come back together for our second learning target. No. I
I was like, I hope
If I can fit it into my schedule next year, as of right now I can, but. 10 on. Okay, it's totally fine by me.
I'm gonna go over there.
All right, last minute or so to finish up the worksheet.